The chemistry of solar panels. The chemistry of solar panels. Solar panels have become an essential technology in helping us to reduce our reliance on fossil fuels, and hence, reducing greenhouse gas emissions. The basic principle behind solar panels is that they generate electrical energy by utilizing the energy from sunlight. In this article, we will explore the chemistry behind solar panels and how this chemistry enables the generation of electrical energy from sunlight. The chemistry behind solar panels is based on the photovoltaic effect, which is the process by which certain materials are capable of generating a flow of electric current when exposed to light. This effect was first described by a French physicist, A. E. Becquerel, in 1839. In 1954, scientists at Bell Laboratories, in the United States, discovered that certain materials could generate a flow of electric current through a solid-state device when hit by sunlight. This discovery led to the development of solar panels. The basic components of a solar panel are silicon solar cells. Silicon is the second most abundant element in the Earth's crust, and its abundance makes it an ideal material for use in solar panel production. Silicon solar cells are created by doping, which involves adding a small amount of impurity to the pure silicon material. The doping process can either add electrons to the silicon atoms or remove them. When a photon of light hits a silicon solar cell, it can either be reflected, absorbed, or transmitted. The amount of reflection, absorption, or transmission of the photon depends on the angle of incidence and the properties of the material. If a photon is absorbed by the silicon material, it can cause an electron to be excited to a higher energy level. This excited electron can then move through the silicon structure to the surface of the material. The surface is designed to collect the electrons and send them through an external circuit to generate an electrical current. The surface of the silicon material is specially treated to create an electric field. This electric field can cause the free electrons generated by the incoming photons to move in a specific direction. The electric field is created by doping the surface of the material with a different impurity than the one used in the bulk of the material. When the two materials come into contact, a p-n junction is formed, where the excess electrons in the n-doped material diffuse into the p-doped material, creating a depletion region. This depletion region acts as a barrier to the movement of electrons, and hence, creates a potential difference across the p-n junction. The electric field generated by the p-n junction causes the excited electrons to move towards the surface of the silicon material, where they are collected on thin metal strips. These strips are connected to a circuit that feeds the electrons into a solar inverter. The solar inverter converts the direct current, DC, generated by the solar panel into alternating current, AC, which can be used to power homes, businesses, and factories. Solar panels can be manufactured using different types of silicon materials, such as monocrystalline, polycrystalline, and thin-film silicon. Monocrystalline silicon solar cells are made from a single crystal of silicon, which gives them a higher efficiency than other types of solar cells. They are also more expensive to produce. Polycrystalline silicon solar cells are made from multiple grains of silicon, giving them a lower efficiency but a lower cost than monocrystalline cells. Thin-film silicon solar cells are made by depositing a thin layer of silicon onto a substrate, such as glass or plastic. These cells have the lowest efficiency but are the most flexible and lightweight, making them suitable for use in portable electronic devices.